What's up, YouTube? How's everybody doing? So SHSAT day number 1 is down. It's done with, right? We're going to explore problem 65 today. By the way, my name is Greg from GregsTutoringNYC. What's up, YouTube? How's Make sure my mic is going. So SHSAT day. Hello, Miles. What's up? What's up with everybody out there? So a lot of kids took the test yesterday. There's still a whole bunch of kids left. There's, I think, 4 more SHSAT dates. So, and I have a feeling they're going to even add another one on too, maybe. I'm not sure. Hey, Oreo, how you doing? So I don't know if you guys took the test or not yet, but like I just said, there's a bunch of people who haven't. So I'm going to crank out a few more YouTubes pertaining to that. We're going to explore 65 today, and we're also going to do at least one more about SHSAT 9. Go over the 9 ones from this handbook as well. And since 9 should be more geometry based, hopefully what we cover today is going to help with that too, right? So what I'm going to do is resolve 65. We already solved it. I'm not going to spend as much time on it. Yeah. I'm guessing maybe 40% of the kids took it, and there's still about 60% left. So we already covered 65, so I'm not really going to cover it in depth. If you guys want, you can go to my site and get the link to actually where it is. I can post that right here too. Give me 1 second. Let's see here. So these handbook cover-to-cover reviews can be found at this link right here that I'm going to post in 1 second. And problem 65 is obviously going to be in some of the other points there as well. Welcome, everybody. See a few people trickling into the lobby there. Please subscribe to the channel. Some of you might even be taking the SHSAT next year or taking other similar tests, since a lot of these problems are also appropriate for the ISEE, the SSAT, the PSAT, the SAT, the TJHSST, the Bergen County Academy test. So there's a whole bunch of intertwined tests that kind of have a crossbreed of the same examples. Not exactly the same here, but it's kind of good for that too. 64G, where did 64 come in? We're only focusing on problem 65 for this stream. We covered 64 already in the links that I'm giving you there. What we're going to do is explore problem 65 further than what we did in the past. Okay. How accurate on a difficulty level are the questions in the handbook compared to the actual test? Traditionally, the feedback I get is that the actual test is harder. A lot of kids yesterday thought it was easier. You can only take that with a grain of salt, because maybe yesterday's was easier and all the others are going to be harder. But generally, over all the years, most kids feel that generally the test they have on test day is harder than the actual handbook tests. Okay, which makes sense. The handbooks don't cover every single problem. Okay, and they're not going to let the cat out of the bag, so to speak, and give you all the answers. So it's a challenging test no matter how you slice it. Most kids don't get to finish it. In fact, I thought that was an odd comment from yesterday, that even though a lot of kids thought the test was easy, a number of them still said they had to guess like 10 or 20 questions. So go figure. So it doesn't really add up. Remember too, what happens on test day is your adrenaline's all pumped up and so on as well. So it's hard to kind of really get like was the test actually harder, or did they just perceive it was harder, right? I also have stories where I talked to kids the next day and they were like, oh, it was super hard. I think I failed or something, and they get a top score. And there's another kid who says, oh, it was so easy. Oh, man, this slam dunk. And they ended up messing it up. So it's just a matter of perception. We don't ever get to see the real test. Once you guys get to see it, the time you take it, it's never seen again. So it's a hard thing to kind of figure out. But just from feedback over the years, it seems the actual test day is harder, even though kids yesterday thought it was easier. But don't use that as your line in the sand. Um, you should be trying to strive to get as many of these correct as possible. By the way, that's kind of the theme of what we're going to do here today, which is that 65 is already there. The answer's in the handbook. I went over already. I'm just going to kind of keep giving a few little twists to it because they take a topic. A lot of you guys focus just on trying to solve the problems in the handbook or your test prep book, and you never bother to learn what the topic is. So if the question happens to be about exponents, and it was about exponent multiplication, a lot of you guys will just focus on exponent multiplication. But there's other parts of exponents, right? For every exponent question that's on the handbook, there's another 2, 3, 4, 500 questions they could ask you. I mean, there's that many. And every little tweak, every little variation in the question, every word counts. So there's that kind of tweaks. So we're just going to take 65 and explore it. Maybe, I'm guessing this might last half an hour today. All right. So why don't we just start out by actually solving the question straight up as is presented here. So let me shrink down the screen slightly. So I like to look at the figure first, as many of you know, and this is kind of just summarizing it. So I don't look at the words originally, okay? And I'm going to look at the figure. Of every problem, this is how I would do it. So I see what I think is a square, and I see what I think is a circle, right? I'm noticing there's 90 degrees here, okay? Because they give that little squarey thing. That's what that means by definition, okay? Since this is grayed in here, they're probably going to want a shaded area question, okay? Or I should use SH, because SA normally means surface area, okay? So shaded is probably what they're looking for. I don't know the radius. I don't know the size of the square. I don't know the circumference. I don't know the area of either things. So there's not much there. I'm hoping point S is the center. Okay. I do notice that R and P are crossing what looks like they're crossing the circumference. Okay. And that's pretty much all I can grok out of this problem so far. So at that point, I'm going to go into here. Okay. So what I'm going to do is get rid of some of the notes I just made here, just to declutter it for you guys. Because I don't want this to look like just chicken scratch everywhere. So in the figure above, PQRS is a square. Check. Okay. So I like to break the problem down into sentences, and within each sentence, I like to break it down into phrases. So PQRS is a square. Okay. So you check the points to make sure that's that, because there may have been other geometric figures here. Point S is the center of the circle. Check. And point P and R are in the circle, so those 2 points, they do meet the circumference. That's what it means, are on the circle. It means they touch the circumference. Okay. Okay. We also know this is the center. Okay. If the area of the square is 4, the area of the square is 4. Okay. What is the area in square centimeters of the shaded part? So they want the area of the shaded. Okay. So if the area of the square is 4, we know that the area of a square is equal to the side square, right? So if we know the side square is 4, then if we take the square root of both sides, we know the side is 2. So that means this is 2, and that's 2, and that's 2, and that's 2, right? Is everybody good with that so far? So we also know, based on what they told us, that PQRS was a square and that S was the center. Just give me 1 second, because give me a warning about the connection. No, we seem okay. All right. We also know, since PS and SR are both radiuses, so R equals 2, and then this is also the radius. Okay. That's important because we can now get the area of the circle as well. All right? So the area of a circle is equal to pi r squared. So that means in our case, it's pi times 2 squared, or it's equal to 4 pi. Okay? So the whole circle is 4 pi. The shaded area is not what they're looking for. So that's why, for instance, answer choice D is incorrect, because that's the whole circle. So what we're looking for is this part here only. All right? So that's part to whole. So we get 90 over 360. Everybody should know that 360 degrees is the number of angles in a circle. And then we get 1/4. Okay? So the shaded area is 1/4 of the whole circle. So if the area of this circle, I'm going to put TC of this circle is 4 pi, then we're trying to get 1/4 of it, or is equal to pi. Okay? So this right here is pi. So that would be the straight up answer to this question, would be C. Okay? All right, that's tiny for you guys, but now that you understand the problem, that should be okay. So we had to do a bunch of calculations. We had to get the area of the square. We had to compute it. Then we had to mentally, through our conceptual capacity, realize that that was also what the radius was, right? Once we got the radius, we had to realize, oh, we have to get the area of the whole circle first. Okay, once we got the whole circle, we realized, oh, we had to get a portion of it, right? And then finally to compute that. So once we kind of went through all this meandering, there's other questions they could have asked us. For instance, it could have said the unshaded part, right? So now we solved the problem. We're going to do variations of it. So if it said unshaded part, what would be the answer there? Right? Now that we computed the answer and we understand how it's all pieced together, we understand the square being inside the circle and all that kind of stuff like that. So who wants to guess what the area of the square would be? By the way, guys, please subscribe to the channel and please like. There's a whole bunch of people in the lobby now. Please like. I do this for free for you guys. I did all handbook of SHSAT, and they were really simple. I did all handbooks of SHSAT, and they were all really simple. And they were really simple. All the handbook problems you felt were simple? That's good then. That's a good, did you take the SHSAT itself yet? I think you told me above. Let me see here. No, not taking it yet. Okay. Oh, wait, that was Miles. I know you've told me in a past streams, though, so. All right, so what would be the answer for what the unshaded area was? So in other words, if the area of the circle is 4 pi, what's the area of the unshaded? Right? We already know the area of the shaded circle is pi. So then the area of the unshaded, we would just subtract the two, and then we can get 3 pi. Okay? So the area in here, right here, that's 3 pi. And we know that 3 pi plus pi is 4 pi. Okay? Now let's say that this was not the original question and it asks us straight up to do it. If it asks us straight up to do the unshaded one without getting the shaded first, we could still solve the problem the exact same way. Okay? Just if you wanted to do a slight variation, when we did the part over the whole, you could have done 270 over 360. In that case, you would have got 3/4. Okay? And then we would have 3/4 of 4 pi. The 4's cancel out, and we would get 3 pi. Okay? So either way is acceptable and fine. Just however you understand it cognitively, that's a reasonable way to think about it and approach it. Okay? Here's another question. What is the circumference of the circle? Right? They could have given the same illustration up until this point. Right up until here, this could have all been the same. And then we can change this. So now the question is, what is the circumference? Right? So circumference equals pi d or 2 pi r, right? So we know what r is. We computed r was 2. So we would just get 2 pi 2, and that's also equal to 4 pi. Okay? So the whole circumference of the circle is 4 pi. Okay? If I asked you what was the circumference from here to here? In other words, the question was, what is the length of the arc inside the circle? And sorry, inside the square. Actually, I have additional ones of this. So just to be clear, if they ask what was the length of the arc in here, right? X equals what? What would that be? Well, if as we computed on the previous page, if the circumference is 4 pi, this is still a quarter of it, right? This is still 90 degrees. So this squiggly line here is still a quarter of the circumference. So that would also be pi. So this is pi here, right? You might be confused and saying, wait, how could one be pi and the other was pi, the area was pi? Remember, the area is in square units. So when we talk about pi, we're talking about in square units, okay? This is just straight up pi. So for instance, if we computed that the square was 2, let me see where they gave that. It's square centimeters. Okay, so all the answers we're giving is in centimeters. So the area was 4 square centimeters, or pi square centimeters. In this case, it's just 4 centimeters, okay? So in this case, it's pi centimeters. In the area case, it was pi centimeters squared. So they look like they're the same number because they were both pi and 4 pi, but one is centimeters and the other is centimeters squared, all right? Right? For the same note, if we were asked, what is the arc from here to here, where I'm putting this weird thing around it now, so from P to R, what is the length of this arc here? If I call that K, what is the length of K there, right? On the circumference. That would be 3 centimeters, because the whole circumference was 4. And we know this is, again, is 90. We could either do 90 over 360 and get a quarter and take it away, or still go back to the 360, the 270 over 360 and get 3/4, right? 3/4 of 4 is 3. And we also know 3 plus 1 is 4, so we can get that there. So as you see, there's little twists where we can still take the basic question, this part here is constant. That can stay the same, and we're just going to change the end of the question every time we do it. The illustration stays the same, the question stays the same. All right? So here's a good one. If the question stays the same and we remove this, what is this here? Let me call this square unshaded. So this thing right in there. How big is that? Anybody have any ideas on that? What is the area of this right here? What's the area of the blue? How do we compute that? Any thoughts? Well, we already computed that the area of the square was 4, right? And the area of the 90-degree part was pi. So therefore, the area, wait 1 second, my computer is slowing down for some reason. The area of the blue must be 4 minus pi. That's it. That's the area. That's the answer. It's the area of the square minus this part here. So that's like our 5th variation of the question. Here's another variation of the question. I can bring that on another screen here. Give me a second. So again, the same illustration. We're going to get rid of this. Okay, so this part stays the same. Now the question is, what is the length of the diagonal? The diagonal of the square, what is the length of that? How many students from this program got into a specialized high school? From which program? Anybody have thoughts on the diagonal of this here? How do we compute that? Nobody out there? There's a few in the lobby. Come on, guys. Oh, wait a second. My thing just disconnected. Give me 1 second, guys. I don't know if somebody can tell me if the stream is still live? Wait 1 second. I lost the chat. All right, so Alex is asking, how many students from this streams I'm doing now get into a specialized high school? I don't know. I don't keep track of that. I just help you guys. I have my own private students. All my private students get in, but I'm just helping you guys on the internet right now. It ends up being hundreds and hundreds of students. Some of you guys, I don't even know who you are. So yeah, give me 1 second. I have to refresh my browser. All right, it's not showing the screen anymore. Is that good with you guys? Can you guys still see the PDF? All right, anyway, if we know this is 2, wait 1 second. I'm not sure what's going on. Experiencing technical difficulties. Let me make sure the streaming software is going. It's not showing the image on my thing anymore. Most of my students get in. The ones who don't get in, I may have only had those students for about a week or 2. But any student I've had over about 2 months, they always get in. So Because my thing is to rip apart problems. Take your time, really rip it apart, really understand the concepts, stuff like that. So, all right, it's showing it's streaming again. So, all right, so let me go back to that. No, wait, it's not streaming yet. All right, there we go. All right, so this is 2, and this is 2. No, it's still locking up on me. All right, so what this problem reduces down now to is a right triangle with a radius of 2, which means the both sides are both 2, right? So what do you guys know about a triangle like that? Okay, this would be 45 degrees, and this would also be 45 degrees. So it's an isosceles right triangle, all right? So this is our side A, this is a side B, and this is our hypotenuse C, right? So does anybody know what that is by default? If we were to compute it, right? Normally we would do C squared equals A squared plus B squared, okay? So we would get 2 squared plus 2 squared, right? So we get 4 plus 4 equals 8, okay? And then we have C squared equals 8. Then we take the square root of both sides. So C is equal to the square root of 8, okay? 8 is the same as 4 times 2. So we're taking the square root of 4 times 2. Okay. This is the same as the square root of 4 times, the square root of 2, which is 2 the square root of 2. Does everybody see that? So the hypotenuse turns out to be 2 the square root of 2. And that's the answer. That's what we're looking for. We're looking for the diagonal, which turns out to be the hypotenuse. So that would be our answer if that was the question. I'm trying to find new works. I can do it because I finished all my book and reviewed it. So you did all the handbooks, all the prep books? Wow, that's a lot of problems. Like I just said, I do private one-on-one tutoring. I have literally thousands and thousands of examples. So, all right, so that's one of the questions there, which is that, okay? Now, how about we ask this? Now that we computed, so we computed the area of the shaded thing, the original question. We computed the area of the unshaded area. So we computed this here. We computed the diagonal. We computed this here. We computed the arc length right here. We computed the circumference and the arc length of there. We computed the area here, right, as well. So that's about 6 variations we have of the problem. So how about we go and look at this right here? What is the area of this thing right here between the arc and the diagonal? Anybody have any idea what that would be? $64, internet guy? Not sure what you mean by 64. Do 64. No, we're only doing 65 right now. I already did 64. Go look in the streams. I gave the link to that earlier. I can post the link again if you want. That's the link to where 65 is going to be. If you look on that page, you can go back a few streams from this. It might be SHSAT review number 16 or something, all right? Welcome, people who keep coming into the lobby. Please subscribe, please like, okay? All right, Alex, you're not annoying me. You're not wasting my time. You're just wasting your own time by doing this. If you want to join in the stream and participate and learn, that's cool. We went through this yesterday, all right? So if you're going to call me names, it's not going to bother me, but you're wasting your own time. If you want to sit here and learn and get something out of this, that's cool, all right? Your choice, okay? I've had a hard, tough life, and believe me, there's nothing you can do that'll irk me or annoy me. So if you want to sit here and waste your time doing this stuff like this, you're go right ahead, okay? You apologized yesterday for the nonsense you did, and I didn't ban you from the channel. So if you want to continue being a jerk, you're gonna be a jerk for yourself. All right? I'm on here helping people. I'm not here to cater to your nonsense. All right? It's okay. It's okay. Thank you. Thank you. I appreciate that you appreciate what I'm doing. Okay. It's weird because he did this yesterday, and then I didn't ban him, but he ended up apologizing. So I don't know what the problem is here. It takes different kinds. I just let it roll off of me. Like I just said, I've my life hasn't been perfect, and believe me, this is the easiest kind of consideration I could ever have. Okay. I'm just trying to help you guys. That's all. There's nothing, no ulterior agenda in here. All right, Alex, you're either gonna be quiet and participate, or I'm gonna ban you. At this point, that's the choice. All right. So, does anybody have an idea of how to get the blue area here? Well, here's the deal. We already had this here, okay, and we figured out that this was pi, okay, right? We already know the area of the square is equal to 4. So that means half the area of the square, which is this gray part now here, is equal to 2. Right? So that's the answer. It's just pi minus 2. So that's the area of this blue shaded in part right now. Right? Pi is the whole original gray area, and 2 is the hatched off area right here. This is the area of the whole square is 4, then half of it is 2. So it's pi minus 2. That's the area of the blue. The blue arc, or whatever you want to call it. Blue arced area, okay? So everybody good with that? Does anybody have questions relating to this? Let me think now if we can get any other variations of this. So if we were to do something like move the diagonal in a different direction. So if I did this, actually I can bring the screen larger again. So if I was to draw a diagonal this way, what is the area of this here? Okay, well, we already computed the area of two of them. So wouldn't it be pi over 2? If the area of this, of A plus B, right, if A plus B was 2, is pi, sorry, and the diagonal cuts this straight in half, then A and B are congruent shapes. So therefore it would be just pi over 2, right? So that could be another question they could ask you. What is the area of that? Let me see. Here's perhaps a good one. If on the midpoint of here, I was to draw a circle, so let's say this is circle B, okay? What is the area of this semicircle? Anybody have thoughts on that? What's the area of the semicircle? The hatched in part right here. Anybody have thoughts on that? Okay, and again, it's centered on the midpoint of P and S. I could just call that BS. Center is point BS. Two pi. Right. Oreo notices that if we know this length here was 2, then BS's have to be 1. So if the radius is 1 of this circle, the area of a circle, which in this case will be circle B, the area of B would be pi r squared, and then if r is 1, we would get pi 1 squared, and that's just equal to pi. Okay? Same for the circumference. What would be the circumference of B? There's a few ways to do that. It's either pi d or pi 2 pi r. In this case, we know d is 2. So it would be 2 pi as well. Or sorry, it would just be 2 pi. All right. So there's that. Let's see, what other variations can we take on this? We could ask what is the difference of the original circle, area of the original minus the area of B. Well, we originally computed the area of the original was 4 pi, and the area of B is now 2 pi. So the difference we just subtract would be 2 pi. Okay. What other variations can we spin onto this? Let me think here. That might be about it. Let me see, I wrote down some notes on a piece of paper here. I think that covered them all. We had the circumference of the original, the unshaded, the shaded, the unshaded square, the diagonal, the arcs, the other diagonal. So as you can see, we did about 10 variations of this problem. And that's pretty much what the test makers do. They'll take a question and just tweak the daylights out of it. So there's basically 10 years of SHSAT problems on this one question here, because each year they can just change it, even use the same illustration, and just change it up. And every kind of question here kind of can follow that same kind of thing. I'm taking mine day after tomorrow. Nah, you know, you'll survive. You'll do okay. Yep, good luck, and as I always say, not just good luck, but good skill. Good skill, and just keep your A game on. Be calm. Does anybody have any questions about the variations? We just went through all this. Hi, I'm taking it on February 10th, so it's gonna be a while. Yeah, it's probably more tense for you than it is for everybody else, because you kind of have to wait. You had to wait like 2.5 weeks. Don't really know what to study. Just make sure you know your formulas. Here's some thoughts, Oreo. Let me get a clean page on this. Do you know your Pythagorean triples? Do you know your perfect squares? Okay, Pythagorean perfect squares are like 2 times 2 equals 4. Okay, you could also have like 15 times 15. Okay, equals 225. You should know your perfect squares up until 20 times 20. If you don't, I would look at those once a morning on a table that you either handwrite or that you can print out. Okay. You have to email me then, Alex. I sent you my email yesterday. Okay. I would also know 25 times 25 as well. That comes up a lot. Right? So you should know that. Also, there's a group of other numbers that come up a lot that I like to call the low teens. They're teens because there's 16 times, 17 times, 18 times, and 19 times. And I call them low teens because they're going to multiply by 3, 4, and 5. 17 times 3, 4, and 5. Okay? 18 times 3, 4, and 5. 19 times 3, 4, and 5. These come up pretty often. Like a lot of you, if I showed you 48, some of you don't realize that's 16 times 3. But that comes up a lot in a lot of examples on standardized tests and in your homeworks and stuff like that. Yeah, it's worth it. And it ties into the Pythagorean triples as well, and a whole bunch of other kind of math. And it turns out that if you had something like 51, a lot of you guys think this is prime, or 57 you think is prime. Neither of those is prime. 3 can go into here. You do 1 with 2 left over, so 3 times 17, which turns out to be what this category was. 57, 3 can go into that as well. 3 goes into here once with 2 left over, and you get 19. So that's your 19 times 3. All right? Many of you, if you saw 19 times 5, you don't know it. And these numbers come up a lot. And it's not just so much that, so there's a couple of examples that if I had like 450 over, 6 or something, times 3 over something, whatever, you guys need to know how to cancel out. And when you find out with a number like this, like if you had a multiple of 48, which is 96, would be times 2, right? So that's really 16 times 6. Okay, when it really comes into play is, like Oreo just mentioned, like the Pythagorean triples, if this was 3 and this was 4, then this is 5. We know that because 3 squared plus 4 squared equals 5 squared, right? 9 plus 16 equals 25, okay? But why compute this if you just know that this is called a 3, 4, 5 right triangle? Okay? So there's a whole bunch more of those. But even if you're, so if we come back to say this line here, if this was 3 times 17, then this will be 4 times 17, And this would be 5 times 17, right? So if this was like 51, 57, you should be able to have that leap out at you. Oh, this is times 3, right? So to be able to do that with your hypotenuse, given that you could see that it was a 3, 4, 5 right triangle. And some of these you could just do in your head then. It's no hesitation math once you kind of do these kind of things like this, all right? So there's a few of those. Let me try to bring it on the screen. Oh, I spelled it wrong. Let me add something to you guys' screen then. Give me 1 second. One second, I gotta put this on top of that. All right, there we go. So you guys should know all these here. These are all your Pythagorean triples. So we have 1, 1 to the square root of 2, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 8, 15, 17, 9, 12, 15, 9, 40, 41. Okay. There's also 1, 3, the square root of 2, which is talked about up here, which is a 30, 60, 90 triangle. That comes up a lot as well. It does not show up. You did 64. It should. Go back a few streams. Just find the one that's talking about 59, 60, 61, 62, 63, 64. It's not in the title. You actually have to watch the video to figure out where it is. So start each one and figure out which one is about in that range, and then click on it. Okay. All right. So you guys need to know that as well. The 30, 60, 90 triangle. And that also has a Pythagorean triple, which is 1, the square root of 3, and 2. Okay? And then you guys also need to know stuff like the distance formula as well. Okay? But that's really using the Pythagorean theorem to get the hypotenuse as well. Okay, and some of the stuff in the bottom of the screen is about other stuff as well. Okay? All right, anyway, the goal of this stream was to rip apart the different sections of the of problem number 65. So I'm gonna peace out, guys. Please subscribe, please like. It's to your benefit as well. and hopefully you guys have a good time. I'm still going to do a grade 9 stream, and I might decide after that what to do about the Form B questions. It might be worth going over the Rev A and Rev B of those, and maybe some, well, just do spot examples of that, okay?